first word they give us is point. Can anybody tell me what a point is? Right, it's some specific spot in space, right? It doesn't have necessarily any specific value to it, unless it's on maybe a coordinate grid, but yes, it is just some undefined but it is a position in space. And it doesn't necessarily have dimensions. So no dimensions. So if you notice, this is how defined and undefined terms, this one would be undefined. Okay? Okay. And I think we could all give a drawing of a point, right? It just looks something like this. Okay? If you are given a point, they usually give it some name if they're wanting you to go to this specific one, right? So if there was a whole bunch of points on a graph or on a line, and they wanted you looking at a specific one, they're going to give it a name. So maybe like point A. So this would be his notation. All right? And then some real-world examples of these. So things that look like a point would be like maybe the end of a needle. Or the end of your pencil. And we could probably come up with a pretty lengthy list there, but this is the idea. Okay? All right. Our next term is a line. Anybody tell me what a line is, or what we already know about them? Okay, what would it look like? We have to draw a picture, so what would it look like? Okay, it's got to be straight, okay. Okay. All right, so a definition for this one is also going to be, yes, it's an undefined term, okay? And like you guys said, it has a straight path. It shouldn't have any curves or turns in it. So a straight path. It also has no thickness, right? This is not something that's like three-dimensional that we're talking about. And it's going to extend forever, right? There shouldn't be any endpoints on it. So extends forever in two directions. Okay, so back to our drawing down here. If this is supposed to extend forever, I'm going to need to put arrows on the ends of that. Okay? All right, and this line could have some given points on it, right? Like the ones we've been looking at for our assignments the last couple days. Okay? And the notation, or the way I would name a line like this, would be the line AB. But to denote that it's a line, you have to put a line segment above it with arrows on both ends. You have to put the arrows on both ends, or you're not telling me it's a line. Right? It has to show that it goes on forever. You also could name this line BA. The order doesn't necessarily matter. But you have to have this above the letters. Arrows on both ends. Okay? Alright, then we're going to give a couple of examples. There was one on yesterday's notes. What did they compare a line to in the real world problem on yesterday's notes? Or, yeah, whatever day that was. I saw you guys. It's hard to remember. Yeah, a highway. They said if you had some straight highway with mile markers, then that would be an example. Alright, what else? What's something else that you can travel on that would be straight? Yeah, we need it to have the idea that it will continue, right? So maybe like a railroad track, that would be pretty straight, right? Alright. Okay. Next one we're looking at is a segment. So, we kind of had an example of this today. What did we say that a line segment was? Right. A portion of the line containing what? What did it have on either end? Endpoints on either end. Very good. Okay, so a portion of a line containing two endpoints. We also said it contained what? All the points in between. Very good. So also contains all points in between. Okay. Alright, so this should look pretty similar to our drawing of a line, but instead of having arrows on the ends, what am I going to have? Points. Okay. And these would most likely have names, like we said, that we would denote a point. So if I was going to name this, the notation for a line segment is A, B, with a line above it, no arrows, because it does not keep going. That's why it's important if you're talking about a line, you put the arrows, because if you don't, then you're showing me it's a line segment, not a line. Okay? Or again, the order of the letters doesn't necessarily matter, so you could also name it line segment. Okay? And you guys already said a couple earlier that would be good examples of a line segment in the real world. But what's real thing? A pencil, okay, and the eraser and the tip would be like the endpoint, okay? Yeah, a ruler. It's the right idea, right? The side of it, right? Because you don't want it to have any thickness. But yeah. Okay, so those are some good examples. Okay, next one is array. Okay, so a ray is going to be a portion of a line. Kind of like a line segment. But array is only going to have one endpoint. And it will contain all of the all points on one side of the endpoint. Okay? So array would be some line with an endpoint on one end. If the other end doesn't have an endpoint, then it must keep going, right? We're going to put an arrow on the other end. Okay, so let's say this was a point, maybe point B. It said that it also will contain any other points that happen to be between that endpoint and the direction the arrow's going. So if there was another point here, like that. Okay, so whenever you want to name a array, this one, the order does matter. You always list the endpoint first. So the endpoint on this one is B. So I would have to put B and then A. And I draw a line above it with an arrow on one end. The arrow does need to be on this end specifically. So it needs to be pointing this direction. So start with endpoint. Starts the name. So not AB. That wouldn't work in this case. Okay, can anybody give me an example of a real world ray? Right, a sun ray, right? It starts on the sun, so it has some starting point, but it goes off, right? Okay? All right. So next one, we've got an angle. Okay? So the definition for an angle is going to be two rays that share a common endpoint. We call that endpoint a vertex. Okay, so if I was going to draw a picture of an angle, we have this common endpoint that we call a vertex, and it has two rays coming off of it. So there's one ray, here's another ray. Okay, this one you would also be able to name based on the points. So there could also be points on these lines, right? So let's call these points A, B, and C. There obviously could be more points on the lines, right? So you would get to pick if there was more. In this case, we just have the 3. But if I was going to give this a name, I would draw the angle. And say that I'm looking at angle A, B, C. You would want to put the vertex as the middle letter. Okay. Which means I also could name it backwards, right? I could name it CBA, right? And because this part in, oops, I didn't mean to move the whole thing. This part in here is the angle, you don't necessarily have to put the arrows. You could also just put it like this. And we would still be talking about that corner. Right? You also can name it just by its vertex. You could also just name it angle B. Okay, so either put the vertex in the middle of two other points, or just name it off of that. Let's say there was another point right here, D. I could not name this DBC. right? Because that would go out of order. D and C are on the same line. You have to pick one from each line. Okay. All right, and I'm sure we could come up with quite a few real world angles, right? We do like where two walls meet, where your desk meets the floor, right? There's tons of examples. Okay. All right, then we've got a vertex. So a vertex is the common endpoint shared in an angle. All right, now I want to point out now, angle is LE, not angel, angle. So when we're doing this throughout the year, LE, angle. We're not talking about angels. All right, so an example of a vertex would have been like this drawing that we had over here. This point right here was the vertex, right? That specific given point. So that part is the vertex, not the whole thing. Okay? So if I asked you what the vertex was over here, you would just tell me that it is at B. So this one is a point. And if they ask you, you don't have to put the dot in front. I would know you were talking about a specific point if you just put the letter, right? So you could just tell me that the vertex here is at B. I would totally talk about. Okay? All right. On to the back. All right. So next one, we've got, guys, we've got a plane. So this one is going to be another undefined term. But for our purposes, we've got basically some two-dimensional, right? A plane that you guys, like a coordinate plane, when you plot points on it, is two-dimensional because you've got your x-axis and you've got your y-axis. So this is going to be a two-dimensional object that extends in four directions. Okay. A plane must also include, I'm going to have to scoop this up, four directions. Okay. It also contains at least three non-collinear points. Okay. So you guys kind of already have an idea of what that looks like if we kind of compared it to a coordinate grid. Whenever we have a coordinate grid, it goes left and right both directions, and it goes up and down. So that's the four directions it's referring to. So this could be any shape. It doesn't necessarily have to be a square. We've got some plane here. Okay, and we'll call this plane L. Plane L has to have three non-collinear points on it. So any three given points. Non-collinear just means they can't be in a straight line. which we'll get to. So you could name this two ways. You could name it, you would draw like, this is kind of like a rhombus, you know, where it's kind of slanted. That's what I'm drawing here. I'm not the best. But you could name it based on 3 points. You could pick any 3 points that are on the plane. So you could name it plane ABC in this case. That's 3 points that are on there. Or they usually will put in a different font or some other way than a coordinate point is written, the L or whatever they call it. So you could also name this plane L. And you'll be able to tell if L is a coordinate point or if that's what they're naming the plane, because it should be differentiated in some way, like italic or in bold, something different. It'll make it different on the screen. All right. Then we're going to talk about collinear and non-collinear points, right? So collinear are points that are on the same line. So that would be like I have some line here, some straight line, right? And then points that are on this straight line. Okay. So if I asked you what are the collinear points in this picture, you would either write it as point D, point E, and point F, or you could write it as points D, E, and F, just making a list. Okay. Okay. All right, then we've got coplanar points. Well, if collinear means points on the same line, coplanar probably means points that are, okay, so points on the same plane. Okay. So if this is my plane here, I would have some points on it. Or, like before, they might name it like plane M or N or L, something like that, and they'll make it different in some way. So if this was plane M, it'll probably be up in that top corner. If I asked you what are some coplanar points given in this picture, you would do it kind of like you did here. Point A, point B, and point C, or points A, B, and C. Okay, intersection. You can have an intersection for different kinds of things. So, yes, that's what it's going to look like, right? If we had two lines that intersected, he said it would look like this. Okay, so our definition is going to be point or line where two objects or more meet. drawing for this one, I'm going to take a little bit of space, so I may have to also go into the one below it, because we can have, exactly like he said, maybe just 2 lines like this. And that point right there would be their intersection. Let's say that that's just some point B. Okay. If that was the case, I would say the intersection is at point B. Okay. You also could have maybe a plane that intersects with a line. Okay. We would also probably say that these are intersecting at whatever point this goes through. So I know you can't really tell because I'm no artist here. But my plane, I'm going to say, is like this. Okay? The line I drew went through it, came out the other side. So they're just touching at that one spot. Does that make sense? I know I'm not very good at drawing, but that's what I was trying to do. So, okay? So that's our second example. Okay, we also, this one's going to be really hard because I'm really bad at drawing. Okay, I'm going to have to draw this in the one below because we kind of ran out of space here. But maybe I have some plane like this. And some other plane like this. So what that means is that, like, I have a plane that's going this way and then a whole plane going through it, like it would slide in if I had these things, which I probably should have done for an example, but didn't think about that ahead of time. Then they wouldn't just touch at one spot, right? They would touch all along the line where they intersect. So they would be touching all along there, right? Okay. So these would be touching all across here. And that would be whatever that line was, so whatever we named it. Maybe line L in this case. Okay. So I would just say the intersect here would be at line L. If it had coordinate points on it, like if it has A and B, you could say that they intersect at line AB like this, if there's points on it. Okay. So I know I'm not the best artist, but I hope that I kind of got my point across there. Okay, and then just like we said, like we listed non-collinear points, that obviously meant not in a line, since collinear means in a line. You can also have points that are non-coplanar, which would mean they are not in the same plane. So I might have like a plane, you don't have to draw this just for reference, but like a whole separate plane over here, just because it's one in here and one in here. Those would be non-coplanar because they're not in the same plane. I'm not going to make you draw a whole extra. That's what the 2 extra boxes were actually for, but we don't need to do that. We just know it's the opposite. Okay? All right.